So now what we want to do is we want to talk about proofs with these indexed collections of sets. But before we get into proofs, we need some preliminary facts and some reminders of things that we might have seen previously. So there are a couple axioms that are going to be helpful to us. So the first one is called the well-ordering principle, which says that every set of positive integers has a least element. So if you have a set that contains only positive integers, there has to be a smallest one. And then the next axiom is going to be the Archimedean principle. And it says for every real number x, there is a positive integer n such that n is greater than or equal to x. So for any real number, you can always find a positive integer that's greater than or equal to that number. So take any kind of real number you want. I don't know, let's look at x being, 4,065,032.34. Then what would n be? I need an integer bigger than that. And so n could be, just round up to the next integer, 4,065,033. Okay. And then there's this corollary to the Archimedean principle, which says for every for every positive real number, so remember R plus means positive real number, there exists a positive integer. So I can just say, I'll just say z plus for positive integer. Such that 1 over n is less than epsilon. So any real number you pick, you can find an integer so that 1 over that integer is smaller than epsilon. And the last thing I want to remind us of before we look at proofs is remember what it takes to prove two sets are equal. So let's say I want to prove A equals B. Right? So I need to show that X is in A if and only if X is in B. And remember this if and only if, it's a biconditional statement. It contains two conditional statements within it, namely, if X is in A, then X is in B, and the reverse, if X is in B, then X is in A. So if you're proving two sets are equal, you're going to have two parts to your proof, okay? you're going to have to establish this fact and then this fact.